Alright, so today I'm going to record a quick video here on Java constructors, which are a special type of method which gives state to an instance. So that's just a fancy way of saying that we're going to initialize the values or fields within an object. And they are invoked by using the new keyword as I have below here. So we have the scanner class, then we have this scanner instance, notice the lowercase, and we let that equal to a new instance of scanner, and then we pass in this parameter here, which is standard in. And you will have seen this if you've done any kind of input from the user kind of exercises. There are several different types of constructors. So we've got the no argument constructor, which is also sometimes referred to as the unparameterized or default constructor. Default because the Java compiler automatically adds it to our code if we don't explicitly state its existence, which you'll see once we jump into the code. Then we've got parameterized constructors, which we had before with scanner. So this is where you pass in parameters which are used to set the values of the fields in your object. Then we've got chained or linked constructors. So these are when you mix and match different constructors in order to basically have more complex initialization of your fields. And then finally we have copy constructors, which is just a special case of parameterized constructors, where rather than passing in regular parameters, we pass in an already existing instance of the object we're trying to make in the constructor. So that's it for the slides. We're going to jump into the code now. Alright. Now that we've talked about constructors in the abstract, we need to actually put them into practice. So for that, I've got a simple object here, which describes a bank account. So we've got some fields, which is our name of our owner, the time at which the account was opened, the bank balance, and then how much they're allowed to take an overdraft. And of course, this isn't truly representative of what a bank would have on you. They'd have a hell of a lot more information, and that's represented here by these square brackets and dots. So the first type of constructor is pretty simple. It is just no parameters. And you can select that by pressing the select none button. And this is the parameter that is automatically added by the Java compiler. And we can see this. If I remove this and I go to my out folder, of course, after having built this, so let's just call it real quick. We'll say bank account equals new bank account. And then let's run this so it actually compiles. Okay, so now it's compiling. It'll give it a second because there's more files here. Okay, now we've got under video, we've got bank account. And it's added this constructor here to our code, even though we don't have it specified here. So that's why this empty constructor is optional. But usually if you're planning on using it, it's nice to have, just so you know it exists. Even though as Java developers, we know that the compiler is going to add a empty constructor for us. So this is how you call an empty constructor. It's simply new bank account, and then nothing inside the brackets. So right now, there's no values to any of these. They're either null in the case of objects or not initialized in the case of primitives. Which means if we really try and access these, all we're going to get is a null pointer exception, or just a straight up error if we try and access the primitives. So that's why we have constructors to initialize the values. So one, for example, which you could use is a constructor which initializes all values. And it looks a little like this. So we have public, then the name of the class, no return type because it's a special type of method. Then we've got all of our fields in the order that they are defined. And then we simply let one equal to the other. So this keyword refers to the field. And that way we can differentiate between the local variable to the constructor and then the field scoped variable, which is here. So this.name, if I click it, it highlights that it's referring to this. And if I click here, it's referring to this. So now we can define a bank account given all the details, and we can actually do stuff with it. So we can pass the name, which I'll use Rian. Then for time opened, we can just do local date.now, which refers to the current time. You don't need to worry about the date time object if you haven't used it before. Then balance and overdraft allowance. For those, we'll just pass 0. And then D to signify that we're passing a double. Okay, now that we've defined a bank account with a regular constructor, we can actually call it. And of course, it's not going to do anything. But what we could do is we could create a toString function. So if you press Alt Insert, you can create a toString, which basically just returns a string of all of the values within the object. And this is pretty useful for things like debugging, or if you want to serialize or store the data within that object somehow. So in order to print out the values, we can type system.out.println, and then we can type account.toString. Now when I run this rather, it's going to print out bank account and then all of the values. So we have a constructor, a parameterized constructor now, and we have a empty constructor. Well, we can call one constructor from the other. So if I want to create a default bank account, I could say this.name equals Joe Blogs. And then I can say this dot time opened equals local date.now as well. This dot balance equals 0, and this dot overdraft allowance equals 0. And this would be our default values for the object. Alternatively, instead of doing all of this, we could just call this constructor. We could chain them. So in order to call another constructor in the same class, we use the this keyword. And then we just simply use it as we would here. And in fact, we can straight up copy this and put it in here. So now I'm creating a default bank account. And if I get rid of all of this, like so, and I call the constructor to print out, it's going to give me the same values even though I'm not giving anything, because I've set the default values here. And this is pretty useful because what if we want to define a bank account, but we don't really need to specify the time, and most new bank accounts don't have any money in them. So the only thing we really need to specify is the name and the overdraft allowance, for example. And here we can do that. But I'm going to get rid of this, and I'm going to call this constructor like I did up here. And I'm going to pass name. I'm going to pass local date.now. I'm going to pass 0D. And then I'm going to pass overdraft allowance. So this is basically using only two default fields, and that being the time opened and balance, because they're always going to be the same. And now we don't have to specify every field. We've got some defaults. And that's usually what you want. So that is constructor chaining and having multiple constructors. So we could use any mix and match of these constructors. So I could say account 2 is a new bank account, but then specify the name and the overdraft allowance, which could be €100. And then I could give every piece of information like we did originally. So account 3 is new bank account, and we can call this Mary. Give it the local time now, and then 00. So this basically just gives us options into how we're creating our objects, because generally speaking, if we're trying to make as generic code as possible, we want to have many different ways of creating our objects. And that's basically it for empty constructors, which we have here, parameterized constructors, which we have here, and then chaining constructors, which is here. But we have one type of constructor left to talk about, and that is the copy constructor. Well, the copy constructor is pretty straightforward. It is a regular constructor, so I can call it bank account, same as the others. But in this case, our only parameter is going to be a bank account. So maybe this represents an account which became dormant and we want to reopen it. Well, in this case, what we could do is we could set the values per the account. So we could say account dot. Now in this case, I'm not going to use setters just because I haven't created them. And I could say time opened equals new, or rather local datetime dot now. And then I could simply pass in the account dot name, account dot time opened, account dot balance, and account dot overdraft allowance. And actually we don't even really need this because we can just put this here. And this should work for us. So we're basically creating a new copy of this account with all of its old values, but we're changing the time it was opened. So if we wanted an example of this, we could have our account, which is here, and we could reopen it after having slept. So time dot sleep. Oh, I can never remember what it is. Sleep. Oh, it's thread.sleep, isn't it? Yeah. And then we could wait a whole bunch of time. And then we could create a copy of the account. So first let's print out the value of account to string. Then let's wait. And then let's print out the value of new bank account. And then let's pass account. And we can get rid of this. So we are opening an account, then we're waiting a certain amount of time, and then we're recreating a new account with the same name, balance, and overdraft allowance, but with a different time to open. So we can use this here. It's going to wait a few seconds. 100 seconds actually. So let's just cut that down a little bit because I'm very silly. We'll go with 10,000 rather than 100 seconds. So we print out the first one, and then 10 seconds later, we'll print out the second. There we go. And you can see that there's a difference here by 10 seconds in the time opened. So that's an example of a copy, a copy constructor, sorry. And that's pretty much everything there is to constructors without talking about inheritance, in which we would have a super constructor. So rather than using this, we could call a constructor in a parent class by super. And then we could work off of that and maybe build upon that. But that's more of a topic for another day.